All right, everybody, welcome to Earth Science. Time for the next page of the lab, where we're going to think about this. If you've been doing all the steps so far, and this is making sense, the idea that Hawaii is sitting on a moving plate, riding over a hotspot. So the hotspot is currently, it's active volcanoes are visible, really, recent volcanoes. Through here, you can even see some output from that one, gases. So down here is currently active. This part of Hawaii is going to get bigger and bigger and bigger over the next generation or two, human generation, which is a very short amount of time in terms of geology. But in the meantime, these other islands have moved off of the hot spot. So here's the idea. If we can measure how far apart these are, and we know how old the rock is, there's methods of dating rock, which is our last unit, Earth's history. There's methods of figuring out how old rock is. If you've ever heard of carbon dating, it's kind of that same idea, only with different isotopes that last a lot longer. If we can date that rock, we know how old they all are. We know how far apart they are just by measuring, which you're going to do. Then we can figure out the rate, the speed that this plate is moving. Now, rates you're used to maybe doing like miles per hour. That's a convenient rate for us to use with the cars we have and maybe even the bikes we have, right? That would be absurdly low in this case. We're more interested in a rate. What we're going to do here is centimeters per year. How many centimeters does the plate move each year? So if this were a normal year, you'd be doing every single one of these. I'm going to shorten it and have you do this twice. All right. I'm going to do the first one as an example, which isn't going to count for you guys. You will have to do two other sets of these. So here's the concept. From this island, Kauai, to this island, which I should really learn to pronounce. How far apart are they? Now, the Google Earth Tour is all set up for you to do that. If you've followed along and you've been paying attention, what you'll do is you'll double-click Kauai, and it will fly you there. Perhaps. Having this like recording software open, there we go. Slows you down a little bit here. Hopefully yours is working smoother than this. All right. I don't know why that was happening, but if you double click some different ones, it'll work. So there is a volcano, long extinct, on the furthest out island of Hawaii. So now we're going to do the measurements that you guys practiced. You're going to click that measurement tool right there. This turns into a little plus. You click once, and then this line is going to follow. I think the easiest way to do it is to go back. You can manually slide yourself back down there, but if you just go over here, it's all preset just to fly you right to it. But it turns your line off. All right. That works in the normal version of Google Earth. This browser-based version apparently does not. So you're going to have to get good with this. Zoom out by using two fingers and pulling down lightly on your mouse pad. Then come on back up here and zoom back in by doing two fingers and clicking. Now it tells me that it's that much. Now, that's pretty far, right? And this is going to sound even crazier. I really want that in centimeters. And it's a huge number. I know that. It's 15 million centimeters. But that's going to be what's valuable to us because these things move so slow. If we did it in kilometers, the number wouldn't make any sense. It'd be like 0.0000 something, right? So those two are 15,379. 15,379,529. That's how far apart in real life those two volcanoes are, from that volcano to that volcano. All right. Now, how much time passes in between them? Here's another problem in this lab. 4.6 million years and 3.7 million years. That is not 4.6 minus 3.7. It's 4.6 million minus 3.7 million. So you got to, in your head, you got to know that that's the way that we do this. What are the chances I can find a calculator quickly? Excellent. So what this math really is 4 million. 4.6 million means 4,600,000 minus the age of this one, which is 3,700,000, which equals 900,000. So 900,000 years passed in between the ages of those two volcanoes. 900,000, which is great. Now, if you do 4.6 minus 3.7, we're not going to be speaking the same language. If that were the case, this plate's going to be flying because you're not going to get 900,000. So you really got to do that in millions of years. Now, could you have done that and then converted to millions of years? Yes. You would have gotten 0.9, so 0.9 million is 900,000. That's true. Whatever works for you, as long as we do this in years, even though this is in millions of years. So the rate of plate movement, how quickly is that plate moving? We just divide those two. Just like you do miles per hour, we're doing centimeters per year. So we'll clear this out. 379,529 centimeters divided by 900,000 years equals 17.08, which is actually pretty darn fast. 17. We can go like nearest tenth on that, so 17.1 centimeters per year. That's it. That's how you do this, okay? Now, I would like you to do that. Instead of doing it all these times, I would like you to do that twice. And this doesn't count for one of them. That one's already done for you. And I'd like you to do it between any two sets of islands you choose. So you can just do, you could do the next two boxes, or you could do, between this one and this one, or you can skip. Like you can go from, maybe what you should do here, this is definitely what you should do. All these little arrows are meant to be if you're doing all of them, right? So let's say you want to do from that Kulau. What do you think? Kulau? Is that how you say that? If you want to do from Kulau to Kulawe, draw little like arrows to say I'm going to go from this one to this one. That way I know. Otherwise, I'm going to have no idea what you did. And then maybe you want to do from Mauna Loa to Loahi. I don't care. Doesn't matter. Pick two sets of them. And if this is all too confusing, skipping some, then don't. Just do two that are next to each other. Do from this one to this one. Whatever works for you. Just tell me which ones you're doing, and you'll be great. Then, since we're not doing all of them, we're going to skip these. So don't worry about doing that. State the general relationship between ages of the volcanoes. And then this is the question we're going to skip right here. Skip that. State the general relationship of the age of the volcanoes and distance from Loahi. So the further away you get from Loahi, the age is getting older and older and older. Okay? Sound good? I'm going to do a separate video for the next parts. That part should be a good chunk of work for you. Let me know if you have any questions. Good luck.